Okay. So, hello everyone. I will introduce myself. So, my name is Davor Petrinović. I will be lecturing this second part of the course, Embedded System Design course. And the technology that we'll be using is simultaneous connection through Teams channel and YouTube channel. This YouTube live distribution, live broadcast has now started, and you can follow it through this channel, but also the video will be stored on the same page, and you would be able to view this video again at any time or download it to your computer. The Teams channel will be used today only to achieve the interactive communication with you. So if you have any questions, you can ask the questions through Teams channel. If you activate the audio through both sources, through Teams channel and through YouTube channel, you would have two audio channels that are time shifted, because the YouTube live emission has a lag of approximately 1/2 minute. So whatever I say on YouTube, if you follow my voice on YouTube and if you ask the question, this question will be actually about something that I said 1/2 minute ago, because the delay on Teams channel is much less than delay on YouTube channel. But nevertheless, you can ask any question. You just open your microphone, ask a question, or make a notification through meeting chat, because from time to time I will throw a look if anybody is writing something on the chat window. And if anything goes wrong with the YouTube broadcast, you should also notify me immediately, such that I can restart it. We had some troubles on the last lecture in Croatian. In the half of the lecture, luckily exactly at the break time, the YouTube channel broke and we had to restart the live emission. Hopefully it will not happen with English lecture today, and we'll be able to have the live channel the full 2-hour period for today's lecture. Nevertheless, if anything happens with the YouTube channel, please notify me immediately through Teams channel. Okay, so just a short announcement regarding the laboratory exercises. As you have been notified so far, for this part of the lectures, we have 2 laboratory exercises, number 3 and number 4. These materials regarding these 2 exercises the materials are already uploaded to the web page of the course. In the English version of the course, you have 2 documents. One document is the description of the laboratory exercises 3 and 4, and the other one is the document that describes how to install the necessary tools that are required for these laboratory exercises. This document was prepared yesterday, and the idea is that we will be using development tools from company Analog Devices. This Analog Devices Visual DSP is a classical integrated design environment that can be used to design programs for these DSP processors in C or in assembly language. And you can then debug these programs using a classical debugger. And this tool will be used for individual exercises. So normally, if you would be still here at faculty, you would be doing these laboratory exercises in our dedicated lecture rooms or laboratory rooms, where we have this software already installed on the computers, and we also have some evaluation boards that have exactly this DSP processor on the board, and that would enable you to do this development and prototyping on real-time signals. Because with this evaluation board, you can evaluate the programs that you have written together with some kind of live signals that you feed to the AD converter, and then the program would take this signal and process it in real time, and again create the output signal that is fed to DA converter, and you could then hear or maybe visualize this output signal on an oscilloscope. This part of the laboratory exercises is currently unavailable, so the only thing we can do is you can install this IDE on your own computer, this visual DSP, and then you can prepare these laboratory exercises as a simulation. So you would write a C program, you would make a simulation and run this simulation in the simulator and prepare the report. So each of you will prepare individual report regarding these two exercises, number 3 and 4, and this report will be submitted to us. Colleague Anita Gribel, she is also currently with us on the Teams meeting. Anita Gribel is the teaching assistant for this part of the course, and she will be helping you in preparing these laboratory exercises, or in this main thing you have to know regarding how to do these two laboratory exercises. She already asked you through this doodle about suitable dates and the times when we can prepare these laboratory exercises in a way that we will be again using this Teams channel the same way as Maya was doing with you for the first part of the course. For the first two exercises, Maya Belotti was doing this preparation and consultation regarding the execution of these two laboratory exercises on announced virtual sessions. The same things will be done here. So we will announce these virtual laboratory sessions through Teams. Anita will start the meeting, and you will be able to join the meeting and to ask any questions. She will also do a short presentation of the whole idea, how these tools are used. She will share her screen on her desktop, and then she will illustrate how this visual DSP tool is used to design a simple project on a DSP. These two particular exercises that you will be doing are actually implementation of a digital filter. So you will be implementing a simple finite impulse response digital filter, and you would simulate the operation of the filter on some input signals. So you can create an input signal, maybe some sinusoidal signal. You have the samples, and these samples will be fed to the actual algorithm that you have implemented in C, and the resulting signal, filtered signal, again a sequence of numbers, would be stored and either visualized in Matlab or visualized as a sequence of output numbers, just to check whether the filter is working properly. The whole thing can be simulated as well as Matlab as a baseline. So the baseline would be baseline implementation of the filter in Matlab, where the floating point representation is used, and you can check whether this filter performs properly in Matlab. And then again, after you implement the same thing in C language on the DSP, you would run the same algorithm but implement it in C on the same input data and check whether you get the same output result as you get on Matlab implementation. In Matlab implementation, it is rather straightforward because you have several functions that you can use to either compute the coefficients of digital filter, and another functions to compute the frequency response of the design filter, and another function to do the actual filtering. So to perform the filtering with design coefficients on a signal that you supply as the first input argument of the filter. Actually, the third input argument. The function in Matlab to do the filtering is actually filter. Okay, so that was just a short introduction regarding the two laboratory exercises that you'll be doing, and all the information will be given additionally through additional announcements on the website of the course, but also on the Teams channel, because the actual virtual session would be held through the Teams meeting. Okay, do you have maybe some questions regarding this? If you have any questions, please write the questions in the chat window of the Teams meeting, and I can answer your questions during the break. Now I will try to go to the actual lecture. The lecture slides are written in Croatian, but actually many slides are in English, so you'll be able to understand it, especially since I will be describing each of the slides in English. So although some parts of the slides are written in Croatian, I hope you should be able to understand the lecture. Okay, so today's lecture is the introduction to DSPs. What are DSPs? In these 3 lectures, or 4 lectures at the end of the semester, we'll introduce a special kind of processors that are specially suited for signal processing, for the application where you want to digitally process a signal. So these signal processors, they have this abbreviation DSP as a digital signal processor. In Croatian it is procesor za digitalnu obradu signala. Okay, so the short summary of today's presentation is introduction, so the survey of DSP processors, then the basics of the DSP architecture. So what is this special DSP architecture different from the conventional CPUs, from the microcontrollers, for example, from the microcontroller that you actually studied in the previous lectures by Professor Vucic. So what is the difference between this microcontroller and these DSPs that will be used to illustrate the concept of how to do the signal processing on the actual hardware, but on programmable hardware, on DSPs. Okay? So this architecture has several major parts. Again, as a normal CPU, you have some arithmetic logic unit, but this unit, this MAC unit, is something specific for these DSPs. This MAC is the abbreviation for multiply and accumulate. So multiply accumulate unit is one special unit that is dedicated to do very fast scalar product. So if you, for example, want to multiply a set of filter state values with a set of coefficients and then add these products together,